we arrive at one of the highlights of this semester, the quadratic formula. The quadratic formula is going to be a razor through quadratic equations. So, all of the methods of factoring that we've used before are going to be handled simply by the quadratic formula. And on top of that, we're going to be able to solve all the quadratics where factoring didn't work. Even more so, we'll be able to solve all quadratics where the coefficients are just real numbers. So they don't need to be integers, they could be any real numbers. Now, the layout of this video, first we're going to do the mechanics of the quadratic formula. For the most part, we're making sure that we're able to do all the use of the formula, what are the common errors, what things do we want to watch out for when we're doing our work. Then we'll talk about solutions, and then we'll do a derivation of the quadratic formula, which you don't really need for your first time out. So, if you're wondering how long this video actually is, the last 5 minutes are the derivation. Now, for the bookkeeping, here's how I do it. We start off with ax squared plus bx plus c equal to 0. Important things here, we have our usual cleanup. I make sure I've got the equal 0 on the other side. For the quadratic, we have to make sure things are in order. So I want descending powers of x. That way I can simply read off the a, b, and c. Now, once we have our a, b, and c, the quadratic formula itself is this ugly looking thing. Probably you want to put it on a note card to memorize for testing situations. One thing we have to help memorize this is it does sort of fit Pop Goes the Weasel, so you can take it or leave it. I'll do this exactly once. What we have, minus b plus minus square root b squared less 4ac, and then that's over 2a. So that's the quadratic formula. Now, mechanics, let's take a look at a basic example. This example we could do by factoring. So I just want to work in a case where the numbers are very clean, so we could just focus on the actual work. We have x squared plus 6x plus 8 equal to 0. So I don't want to work with negative numbers just yet. I pull off the a, b, and c. So a is 1, b is 6, c is 8. And then if we drop this in the quadratic formula, we can do Pop Goes the Weasel. Minus 6 plus minus square root 6 squared less 4, 1, 8, all over 2 times 1. Under the radical, we have 36 minus 32. That drops to a 4, and then square rooting that becomes a 2. So for our answers, we have minus 6 plus minus 2 over 2. Breaking up the numerator, we're going to get a minus 8 and a minus 4. We cut those in half to get solutions. X equal to minus 4 and minus 2. Now, these are solutions to an equation, so of course we should check if we can. I'll check the minus 2. So I put the minus 2 back in the original. The minus 2 goes in with parentheses so I don't mess up the negative sign. We have minus 2 squared plus 6 times minus 2 plus 8. That gives 4 minus 12 plus 8, which definitely goes to 0. And then I'll let you check the other solution. Another important check if we're in the business of factoring, a and b are going to be solutions to x minus a times x minus b equal to 0. So if I take the a and put it in the first part, that's going to go to 0. Doesn't matter what I multiply it by, we'll get a 0 on the other side. Likewise, if we put a b into the second part, b minus b is 0. No matter what I multiply it by, we're still going to get a 0. So this is one way to check against the original quadratic. Now in this case, what do? I've got an x minus a minus 2, x minus a minus 4. They become pluses to give us x plus 2 times x plus 4. We FOIL and we get x squared plus 6x plus 8, which is our original quadratic. So that's a second check if we're in a factoring situation. Next example, we have 3x squared minus 7x plus 2 equal to 0. Note, this is already cleaned up, so all I need to do now is peel off the a, b, and c. and then drop those in the formula. The key to this example is that I want to focus on making sure we do the negative in the b correctly. That's going to be a large source of errors for whatever reason, not using parentheses or just dropping your negative signs. So what are we going to do? We have a equals 3, b equals minus 7, c equals 2. We go into the formula, we have minus 7 plus minus square root minus 7 squared less 4, 2, 3, all over 2 times 3. Under the radical, we'll have 49 minus 24. Note I use parentheses here to make sure that minus sign is not floating. That's going to be a common error. We have 49 minus 24. That reduces to 25, and then square root of 25 is going to go down to 5. So our answer is going to be, okay, note, minus 7 goes to plus 7, so we have 7 plus minus 5 over 6. We separate the numerator, we'll get a 2 and a 12. These are both over 6, so they reduce to a 1/3 and a 2. Note, this we could have done using factoring techniques, but again, we want to keep the example simple to make sure we make our points. Now, you could check this directly by putting in the formula, so I'll leave that to you. I want to make sure we do the factoring check now, just to show you how to handle the 1/3. So remember, what do we do for the factoring check? We're going to do x minus, so that'll be multiplying x minus 1/3 times x minus 2. You could just go ahead and get rid of the fraction by clearing out the 3. I can multiply everything by 3 in this factor, which will give me a 3x minus 1. Why this is an important move, you'll notice if I don't put that 3 in there, we're going to wind up with an x squared. The original has a 3x squared, so that 3 has got to come from somewhere. So either you just clear this like you would normally would to get rid of the fraction, or you think of it as you're putting a 3 in at the end. Now, we clear the 3, so I have 3x minus 1 times x minus 2. I FOIL, and then what comes out matches our original equation. So that's factoring when we have rational solutions. Let's look at an example that factoring can't handle. So this is going to have a square root in it. We're only able to apply factoring to situations where the answers are rational numbers. What we'll have, 16x squared equals 16x minus 1. So note, this is not cleaned up. I need to have an equal 0 on the other side, so I'll move the 16x and the minus 1 to the left. And so they're going to change signs, so we get 16x squared minus 16x plus 1 equals 0. Now we can just peel off the a, b, and c. So we have a equals 16, b equal to minus 16, c equals 1. We drop into the quadratic formula. So we'll have minus 16 plus minus square root minus 16 squared less 4 times 16 times 1 all over 2 times 16. Under the radical, we can get a calculator for this if we need to. That's 256 minus 64. That goes to a 192, and now I've got to look for the largest square in 192, which is going to be a 64. So we'll have 64 times 3. I square root, the 64 goes to 8, and we're stuck with a square root of 3. Minus 16 is just 16, so our answer is going to be 16 plus minus 8 square root of 3, all over 32. Now, we note there's some simplifying we can do here because of the even numbers. The way I like to handle this is just to factor the biggest thing you can out of the numerator and see if anything in the denominator cancels out with it. So you could do this business of breaking things up into 2 pieces and whatnot. This is a little bit quicker. Okay, so for the numerator, I notice the biggest factor in 16 and 8 squared root of 3 is an 8, so I can pull that out. When I pull that out, what's going to be left over in the 16 is a 2. What's left over in the 8 squared root of 3 is just a square root of 3. So that's 8 times quantity, 2 plus minus square root of 3. In the denominator, well, I want to pull an 8 out of this, so that'll leave a 4. The 8's cancel, and then our final answer is x equal to 2 plus minus square root of 3 over 4. And then maybe we don't want to check that. You could. That's an exercise in square roots. And for factoring, we need a little bit of trickery to get around making that work. Last example, let's consider 4x equal to x squared plus 13. Here, we're not cleaned up. We need to equal 0. So to get things in order, we're going to add a minus 4x to both sides. We'll flip the direction. I'll get x squared minus 4x plus 13 equals 0. The x's are in descending order of degree. So we'll have a equals 1, b equal to minus 4, c equal to 13. We drop it into the quadratic equation. We have x equals minus 4 plus minus square root minus 4 squared less 4, 1, 13 all over 2 times 1. What's under the radical? Okay, we need to take care with the negative 4, so I put that in parentheses. 16 minus 52, which is going to be a minus 36 under the square root. So this will have complex numbers in it. Out in front, I've got a minus 4, which is going to go to a 4. So our answer will go to 4 plus minus square root of minus 36 over 2. For the square root, I break it up into 36, which comes out as a 6. Square root of minus 1, remember we switch over to notation, the letter I. So we'll have 4 plus minus 6i over 2. If I want to clean up, because I notice they're all even, I'll factor a 2 out of the numerator, which will give me 2 times 2 plus minus 3i all over 2. The 2's go away, and we get rid of all the fractions. I've got 2 plus minus 3i for our answer. Again, we could check this directly in the original equation, and of course you should check it in the equation that hasn't had algebra done to it, the original. Let's do our factoring check though, just to try that again. Now this is a little advanced, but it's nice to see at least once to see how things go. To make this work, we're going to have to make use of a difference of 2 squares, and that'll come in from rearranging things. So what do? We're going to take x minus. I put our solutions in, so 2 plus 3i, 2 minus 3i. To get rid of the parentheses, I got to distribute the minus sign. So x minus 2 minus 3i, x minus 2 plus 3i when we get the minus minus. Now you'll note, not looking so good. We've never learned how to multiply a 3 on a 3, but what I'm going to do is make it 2 on 2 by putting parentheses around the x minus 2 in both terms, and we're going to treat those as units. So those are going to be 2 things on 2 things as long as we count the x minus 2 as a 1 thing. Now, if we put boxes around this, you'll notice we're doing a difference of 2 squares. These items match for your A, these items match for your B, the 3i, and then we've got different signs. So that's just going to be first times last with a minus in the middle. That'll give you x minus 2 squared minus a minus 9, because 3i times 3i, what do? We get a 9. I squared is a minus 1. Now I've got x minus 2 squared plus 9. We FOIL the x minus 2 squared because that's x minus 2 times x minus 2. And when you sort all that out, you get our original quadratic back. And that, like I noted, is an advanced trick. So there's a lot to explain in here much more carefully. Now, you'll notice we've gotten all the solutions we could expect had we studied radicals, where you can have rational solutions, you can have solutions with a square root, you can have solutions with a complex number. We could tell ahead of time from the ax squared plus bx plus c equal to 0 what's going to come out, because everything depends on the part which is the plus minus square root of b squared minus 4ac. The thing that determines this is the square root. What happens with square roots? If 0 goes into a square root, 0 comes out. Plus minus 0 is just 0. So the plus minus really just gives you one thing. If we put a real number into a square root, well, we get the positive square root out. Plus minus gives us two things. And if we put a negative number in a square root and we're allowed to use complex numbers, we're going to get an imaginary number, a real number times I, and that'll have a plus minus, meaning two complex solutions. So that's the idea. Okay, the b squared minus 4ac gets the fancy name discriminant. I'll use capital D for that. If your d is 0, like we noted, that you're looking at plus minus square root of 0, so you'll just get the minus b over 2a for your solution. And then if you're factoring, you got to put that into your work twice. Save that for the exercises. If your d is positive, okay, then the plus minus square root of d. We note the solutions can't be equal, and they'll be real because we're just doing positive square root. Third case, if your d is negative, then you're doing plus minus square root of a negative number, which you break into the positive part, which is just a square root, or the absolute value of d, and the minus 1, which is going to go to an I under the square root. So this is going to look like plus minus some real number times I, and there we'll get the two complex solutions. For example, for some things we've done, for the very first one, x squared plus 6x plus 8 equal to 0, I could tell right away I've got two real roots. By computing the discriminant, we're going to get 6 squared minus 4 times 8. That's a 16, that's positive, so two real solutions that are not the same. We note the solutions are a minus 2 and a minus 4 as expected. For the complex, let's do the one that's still on this board. So that's the x squared minus 4x plus 13. Discriminant here, we're going to square the minus 4 and then minus 4 times 1 times 13. That's going to give me a 16 minus a 52 like we saw before. I get minus 36. That's negative. That indicates two complex solutions that are not equal. And we already know what they are. 2 plus minus 3 times I, which are definitely not the same. Finally, let's give the derivation of the quadratic formula. This isn't so important as the earlier parts in the video. We're mostly interested in mechanics, but we should be complete. Now, this is just going to be a big application of completing the square. So let's remember the version of completing the square that I'm using. If I have x plus 2ax, I'll take what's in front of the x, the 2a, I'll cut it in half, and then I could just drop the a into x plus a squared minus a squared. For our first step, we're going to solve a special case. So there's not going to be an a in the equation I solve it first. We're going to solve x squared plus capital Bx plus capital C equal to 0. And later we'll use small b and small c. Now, I'm going to apply completing the square to x squared plus bx. What's in front of the x is a b, so that's 2a. We cut it in half to get b over 2. I drop it into the right-hand side of completing the square. So I'll have x plus b over 2 squared minus b over 2 quantity squared plus c equal to 0. We want to clean this up so we can isolate the x plus b over 2 squared term. The b over 2 squared is going to go to b squared over 4. It has a minus in front, so if I move it to the other side, it becomes b squared over 4. The c, when we move it over, becomes a minus c. If I want to put everything over a common denominator, I'm going to change it to minus 4c over 4. So we have b squared minus 4c over 4, and we see the discriminant in the numerator. Next, we apply the square root property. So if I want to remove the square from x plus b over 2 squared, we plus minus and square root the other side. That's going to give us x plus b over 2 equals plus minus square root of, and then a fraction, b squared minus 4c over 4. I could take the square root of the 4, and that's going to become a 2. We move the b over 2 to the other side, and that gives us as a solution x equal to minus b over 2 plus minus square root of b squared minus 4c. over 2. And to make what's going to happen on the other side a little bit easier to look at, I'm going to pull the 2 out as a 1/2. So we'll have a minus b over 2 plus minus 1/2, and then quantity square root of b squared minus 4c. This we're going to bring over to the other side now. The way I get the full formula, we're going to let capital B just be equal to little b over a. I'll let capital C be equal to little c over a, and then just drop it into the formula we were using here. So what's that going to turn into? Well, we had capital B over 2. So when I drop this in, that's going to become b over 2a minus b over 2a. Looking good so far. Plus minus 1/2, and now the radical will turn into b squared over a squared, that's capital B squared, minus 4c over a. And I'm going to multiply by 1, a over a, so I'll get a common denominator. So that'll become 4ac over a squared. Next step, what do we have now? Minus b over 2a plus minus 1/2, and then there's a square root b squared minus 4ac over a squared. If I take the square root of the a squared, that just becomes an a, and we put that together with the 2. That gives us our quadratic formula. Now, what did that just solve? We also got to back out the original equation here to make sure I get the ax squared plus bx plus c equals 0. So let's check that. We take the equation from over here. I'm going to drop in for capital B, little b over a, and for capital C, little c over a. And with this equation, I just want to clear the a's out of the denominator, so we'll multiply every term by an a. This is an equality, so multiplying both sides by a doesn't change that. And that's going to reduce to ax squared plus bx plus c equal to 0 as promised. So this quadratic formula is a solution to this equation.